Nvidia just fundamentally changed the tech powering ray trace games. Officially unveiled at Gamescom 2026 alongside Game Ready Driver 580.88, the company introduced the second generation of its AI-driven denoiser. For years, conventional rendering relied on hand-tuned, manual denoisers. Accumulate enough light samples over multiple frames, or noise ruins the image. That era is officially fading out. DLSS 4.5 Ray Reconstruction doesn't just filter raw sample data. It reconstructs radiant light paths dynamically from sparse ray samples. Built on a second-generation transformer model trained on NVIDIA supercomputers, it packs 20% more parameters and 35% more compute capability to resolve complex light transport far faster than traditional pipelines. Fine geometric meshes dissolving into temporal noise? Fixed. Fire smearing into orange soup? Cleaned up. The terrifying part for competitors is neither rival upscaling ecosystem currently has a reconstruction model this deeply trained. Let's dive into what NVIDIA changed under the hood. While DLSS 3.5 originally introduced transformer-based ray reconstruction, this 4.5 upgrade unifies super resolution and denoising into a single neural network. By evaluating spatial and temporal engine data simultaneously, it specifically resolves multi-bounce path tracing calculations. The result is a wildly more accurate interpretation of shadow penumbras and crisp specular reflections, especially on metallic surfaces, wet asphalt, or within volumetric fog. Crucially, NVIDIA confirmed this second-gen model is backward compatible across the entire GeForce RTX lineup, running directly on tensor cores from the RTX 20 series up to the RTX 50 series. Community reaction following the Gamescom reveal has been electric, with reviewers stress-testing 30 supported titles through the Nvidia App override feature. Forums are flooded with side-by-side captures from Cyberpunk 2077, Alan Wake 2, and Doom: The Dark Ages. The main highlight is subpixel geometry and motion stability. Previously, thin structures like intricate iron grates or distant stone arches shimmered during camera movement. With 4.5, the upgraded transformer model shows massively higher temporal stability. In high-motion scenarios, like driving through rain-soaked night city streets, users report a massive reduction in boiling artifacts on reflective ground. Independent testing confirms this comes with practically zero performance regression compared to the older model. Most importantly, DLSS 4.5 directly targets the biggest criticism of first-gen ray reconstruction: image softness and face smearing. The original model was widely criticized for washing out skin details and leaving characters looking distractingly waxy. By deploying expanded training datasets and deeper spatial awareness, the second-gen transformer model restores crisp, natural details to microtextures without introducing harsh, artificial sharpening filters. Motion clarity enthusiasts note that fine geometric edges remain sharp even during rapid camera movement, giving path trace titles the clarity of native rendering without the heavy temporal noise. Performance benchmarks confirm that enabling the new ray reconstruction model does not impose a mandatory frame rate penalty. On mid-range hardware like the RTX 3060 and RTX 4060, frame rate impacts remain within a negligible margin of error, making high-end ray reconstruction practical across the entire user base. In heavy path tracing, GPUs handle particle effects like fire, magic spells, and explosions with significantly fewer visual glitches. In Hogwarts Legacy, where fast magic particles cause severe trailing, the new model holds color data far more accurately. Ghosting behind bright, fast-moving objects is visibly reduced across the board. The technical community uncovered that users can easily test the new model today in supported games using preset F under the DLSS override settings in the Nvidia app. Gamers are already applying this override to titles like Black Myth Wukong and Cyberpunk 2077 to swap out older reconstruction models. While competitive shooters like Call of Duty Black Ops 7 still favor raw frame rates over heavy lighting pipelines in multiplayer, single-player modes benefit immensely from stabilized shadows and eliminated temporal artifacting during rapid camera movement. Driver updates also resolve long-standing engine-level denoiser bugs, such as glowing foliage and ambient occlusion misalignment in complex geometry. This Gamescom release represents a clear strategic pivot. By distributing Ray Reconstruction upgrades via continuous software and driver updates rather than locking them behind new silicon generations, NVIDIA treats neural rendering as an evolving service. Open-source alternatives currently face a massive hurdle due to the sheer volume of training data required to build a comparable transformer denoiser. When a camera cuts from bright exteriors to dark interiors, the transition delay for the denoiser is drastically shortened. In Cyberpunk 2077, the brief flash of noise when exiting a car or entering dark doorways is effectively eliminated. Deep learning engineers note the second-gen transformer replaces older convolutional and U-Net denoiser architectures by aggregating lighting from a much wider spatial context across the entire frame. This is why it handles thin occluders and fine geometric masks significantly better without breaking frames into isolated tiles. The future inevitably points toward a fully unified neural network handling super resolution, frame generation, and ray reconstruction simultaneously. This DLSS 4.5 release is our closest step to that reality. If you found this deep technical breakdown useful, please take a moment to like, subscribe to Tech Market Pulse, and hit the notification bell so you never miss an update. Thanks for watching, and we will see you in the next video.